We're going to review the t-tests. T-tests we saw are an important tool in using hypothesis testing to test some hypothesis about a population parameter. We saw how this was related to estimation and the idea you can take a sample, generate a statistic, and make a statement about where the population parameter lies. Remember that for t-tests, we've basically set up two types of research questions that we can ask. The first is the idea of a one sample t-test, and that is your population mean equal to some given value, some hypothesized value? And we were explicit in saying that we're going to set a null hypothesis for that test, and that null hypothesis can come from anything. The average Frisbee fits 72 ounces of liquid, or the average person, we usually write this with a colon. The null hypothesis might be that the average person, mu, right, the population parameter, the average person has 99 problems. Then we can go out and we can collect some data, calculate a mean of our sample. Maybe we get an average of 96 and a half. And then we can say, what's the probability of getting that result if the null hypothesis were true? Now, 96 and a half, 97, not too far from our hypothesized value. So we might find that that's not statistically significant. We have no evidence to reject this null hypothesis. But if you went out and you found that the average person has, I don't know, 6 problems, the song wouldn't sound as good. But if you had 6 problems, that might be evidence. That'd be pretty weird. If the truth was 99 problems and you found an X bar of 6, you might say the probability of getting that by chance alone is pretty small. So we'll go and we'll reject that null hypothesis. So through p-values and using the alpha level as a cutoff for statistical significance, we saw that we can do this one sample t-test and say, is the population mean given to an equal value? And we generalize that and we introduced the idea of the independent two-sample t-test, where we took 2 groups of people and we measured them on some continuous variable. Here's my box plots. Here's my 5-number summary of them. And say we had some grouping variable that defines the 2. And then we looked at the mean. We could ask research questions like, are 2 population means equal? Again, we always want to think about what is the research question. So this is a review of where we're at. And I want to show you some data, and we will look at some t-tests. Imagine that you had 2 groups of people. Group 1, let's say that these are New York Yankee fans, and then group 2, say these are Boston Red Sox fans. And we have 12 people in this group, and we have 12 people in this group, and we measure their happiness on a scale of 0 to 100. Now, we can debate, is happiness really a continuous variable? Does it make sense to put a number on it? But let's say that we have a scale here and we think that it works. Now, the first thing we always do is look at our data. So take a look. What do you see about these 2 groups? Well, there's a lot of overlap. If I told you that my happiness right now, how does it look? 70? Would you be able to tell if I'm a Yankees fan or a Red Sox fan? Not really, because there's a lot of overlap between this group and between this group. So by looking at your data, it might be easier to take a little visualization, and we can do a little box plot. Here's a box plot of these data. We have our 2 groups. These are the Yankee fans here, and these are the Sox fans here. And you can see that there's a lot of overlap. Now in Stata, if you want to make these box plots, you can run the command graph box, and then put your outcome or your dependent or the y variable, the variable you're going to make the mean for here, that's score. You can see score right here. And then the variable that defines the 2 groups, and I called that variable group right here. And you can see group. I have group 1 and group 2. So for an independent samples t-test, if we wanted to compare the mean happiness between Yankee fans and Sox fans, we just run this. T-test, oh, this is a typo. This actually should say t-test with no dash in it. T-test score, again, that's the dependent or the outcome variable by group. group there is what we call the independent or the X or the predictor variable or the input. So here's the results and data from an independent samples t-test. And we've seen this. Here's the mean of each group. Here's the difference in the means. Take out a sheet of paper and write that down. 3.9. 3.9 is the difference in the means. And we can look at the confidence interval for that difference in means. We saw that the difference in means is a random variable. Had we taken a different sample, we'd get different people. If we get different people, we get different levels of happiness. Different levels of happiness, we get different mean. Why? Because it's random. Now, notice that this confidence interval for the difference in means, it includes the number 0. That means that our data are consistent with there being no difference in happiness between the two groups. There's no evidence of a statistically significant difference. We can tell that same information by looking at the p-value at the bottom here. P equals 0.41. Now, remember the definition of a p-value? The probability of observing a test statistic of a given magnitude or larger if the null hypothesis is true. And the null hypothesis here is that the average Yankee fan, that's a Greek letter mu, and then I'm writing a Y for Yankees, that the average Yankee fan is as happy as the average Sox fan. That's the null hypothesis. And right here, we have no evidence to reject the null hypothesis. It's not statistically significant. We would say the groups aren't different. Now, my kids know that 65 is different than 61. There is a difference. I mean, mathematically, they're different. But when we say there is no difference, it's implied there is no statistically significant difference. So this is a nice little recap of the independent samples t-test. But why are we doing it now? Because there's a twist. Imagine that you go through this whole analysis. I put a question mark up here. That was a little bit of a teaser or a spoiler that something's wrong, and I'll tell you why. Imagine that you do this whole analysis and you write it up and you say something like this. Watch this. I'm going to use the p-value. I'm going to use the difference, and I'm going to use this confidence interval. And I can say something like, there is no significant difference in mean happiness. There's my p-value. And I can say, there's my confidence interval, which you notice includes 0. Now, some students at this point, they want to start with, we are 95% confident that on the average, Yankee fans are between less than 5 units happy and more than 16 units. And they start the sentence with that. But the problem with starting the sentence with that is it's a long sentence. And most people stop paying attention before the end of the. So what you want to do, I like just to start right away and just say, hey, there's no significant difference. And then if people want to see the details, they can read the details. Okay, good. So good. This is a nice summary if I had two independent groups, Yankee fans, Red Sox fans. But wait, imagine the boss says to you, I screwed up. When I gave you those data, it was not actually a group of Yankee fans and then a group of Red Sox fans. It was actually not 24 people. It wasn't 2 groups of 12. It actually was only a sample of 12 people. And I have to tell you a little bit about the research design. The boss says, the way I set that up is it was the same set of people and I measured them twice. The data aren't independent of each other. I took people and I measured their happiness, some sort of pre-test. And then I did something particularly noxious to them. Maybe made them watch a 7-minute video reviewing t-tests. And then I measured their happiness again and recorded that as the post-test. So instead of 2 independent groups of people, I really have only 12 things that I'm measuring. I'm measuring a happy person, pre and post, and I'm measuring some miserable cuss of a person, pre and post. And if you want to analyze these data, you're going to have to think, I can't do them as an independent samples t-test because they're not independent. So in the next set of slides, we will look at how do I analyze data when the independence assumption is violated, but violated in a very specific, careful way, such that I'm analyzing pairs of data. So stay tuned for that.